Okay, welcome to 11.3, which is graphing trigonometric functions, and we're going to talk specifically about our horizontal transformation, or h value. We've already looked at sine and cosine curves for understanding their period, their amplitude, and shifts involving the amplitude and the k value, or our vertical shifts. Today we're going to look at our horizontal shifts. So as this slide shows here, we have our two trigonometric functions we've been looking at, which is our cosine and sine functions. We have our coefficient out front, which is a, and that's typically involved with all of our functions. Again, that's been our vertical stretch, our shrink, or reflection. Our amplitude is what we call it here for our trigonometric functions. We have our k values at the very end there. That is for our vertical shift. That's up and down, and that's dependent upon up for a positive k and down for a negative k. If you think about it, really the vertical shift, the k value, just affects the output of the function. Now this h value here, again, like in all these functions, it's either in the parentheses or under a square root sign or something like that, or under a radical of that nature. That's our horizontal shift. Like the horizon, it's left or right. If it's positive h, so if we have an x plus h situation, you're shifting to the left, which seems counterintuitive. And if it's negative h, so x minus h, you're going to shift to the right h degrees. Okay? So let's take a look at how this plays out with our trigonometric functions. All right, so here we have an xy axis. Our x-axis is going to be our angular rotation, or angular degrees, or angular measurement. And our y value here is just going to be our output value. If we think about it, 90 degrees is 2 pi radians. Okay? And that's kind of important because that's maybe a fourth of a full period, of a typical period that we'd have for a trigonometric function, sine or cosine. So if I think about it, this right here, I start out at 0 degrees. I start off at pi over 2. I go another 90 degrees, that would give me pi. Another 90 degrees, I'd have 3/2 pi. And yet again, if I go further, I would have 2 pi. After 2 pi, I end up at 5/2 pi. I will end up at 3 pi, and so on and so on. Okay? Going this way, I could end up at negative pi halves, pi, negative 3/2 pi, negative 2 pi, negative 5/2 pi, and then negative 3 pi. What you'll notice, our period, a typical period, is 2 pi radians. So from here to here would be your typical period. And as you see, you have 1, 2, 3, 4, and 5 hash marks that typically go for your typical 2 pi radian period. Okay? Now, thinking about this way, anytime I shift my function by pi over 2 radians, I'm going to see this starting point move either this way or this way. And that's going to be how we're going to start by graphing our trigonometric functions. We're going to start drawing in our x-axis based on and start graphing from the point of the transformation. So our steps in graphing trigonometric functions is we're going to set up an x-axis first that has 5 hash marks. Again, that's one period, where one period is typically 2 pi radians. We're then going to determine our horizontal shift. That's going to come from the x minus h component of our function. Where again, minus h goes to the right, plus h goes to the left. We're going to add pi over 2 for each following hash, so that we have 5 total hashes. And then we're going to draw on our y-axis, and we're going to graph the curve. So in this case, we have our function y equals sine of x plus pi over 2. We want to remember again that typically we look at this and we think cosine of theta. sine of theta is the same as our x and y coordinates. All right, that'll be something to keep in mind. As I look at this, I see that my transformation here is positive pi over 2. So an x plus pi over 2 will represent a shift to the right. Sorry. No, caught myself. A shift to the left by pi over 2 radians. So what we're going to do is, instead of starting at 0 here, we are going to start at negative pi over 2. Because we have shifted from 0 to negative pi over 2 radians. Or maybe it would look better if I did it this way. We would normally start at 0 radians, but since we have shifted to the left, we're shifting to the left negative pi over 2 radians. This would make this 0 radians. This would make this pi over 2 radians, pi radians, and 3/2 pi, or 3/2 pi radians. It's still going to be a full 2 pi radians. And this is going to be our y-axis. In this function, our amplitude is 1. It is a sine function, and sine functions start at the midline. K is equal to 0 here, so our midline is also our x-axis. So our x-axis here is also our midline. Since our amplitude is 1, I'm just going to mark 1 in up above and 1 below. Negative 1 below. Again, since we're going to start at our midline, I'm going to draw my point at negative pi over 2 and a y value of 0. At 0 radians, I'm going to be at 1 pi, or I'm going to be at 1. At pi over 2 radians, I'm going to be back on my x-axis. At pi, I'm going to be at negative 1 radian, or sorry, at negative 1. And at 3/2 pi radians, my y value will be again at 0 on the midline. And so my function will still look like a sine wave, but it's been shifted pi over 2 radians to the left. If you think about it, your normal function would look something like this. As you can see here, I have moved negative pi over 2 radians. This being y equals sine of x. Okay? So again, we shifted it left, negative pi halves radians. If you think about it and you just start looking at it, and if you look at it from 0, and you were to continue this graph all the way to 2 pi, this would look more like a cosine function. I mentioned in the first video that our sine and cosine functions were out of phase by pi over 2 radians. So a shift of pi over 2 radians should take a graph and over a different range or a different interval should make it kind of look like a cosine function. More on that later. All right, so example 2 here has y is equal to cosine of x minus pi. Here we see that our h value is pi, so our x minus pi tells us we have a shift pi units to the right. So if I'm shifting it to the right, instead of starting at 0, I'm going to shift from 0 to pi, and I'm doing it to the right. So our first value we're going to draw in here would be pi. And then we're going to increase by half pi each time. So I go from pi to 3/2 pi to 2 pi to 5/2 pi, and then to 3 pi. I can draw on my y-axis over here. My amplitude here is 1. Since my amplitude 1 is, I'm going to mark off 1 and -1 above and below the x-axis. And for a cosine function, our cosine function will always start above the midline when a is greater than 0, and I'm going to do that in red, or below when a is less than 0. So when a is positive, we're going to start above the midline, and when a is less than 0, we're going to start below the midline. So if I'm thinking about it this way, I'm going to start above the midline at pi 1. I'm then going to go down and cross the intercept x-axis at 3/2 pi. I'm going to continue to go down so that I'm at 2 pi -1. I'm going to come back up again at 5/2 pi to the x-intercept, the x-axis I should say, and then I'm going to finish at the value of 3 pi, 1. And again, this looks like my cosine function. I've shifted my function a full pi units to the right. All right, so let's look at this example. Now we see that we do have some amplitude here that's not 1, so we're going to take a look at it. First things first, we're going to notice that we have x minus pi halves. That is a shift to the right pi halves units. Again, when we're subtracting something, you typically think of movement to the left, but it's actually movement to the right. Okay? So again, we'll go from 0 to pi over 2 to start. We have an amplitude of 2. A is equal to 2. And we see it as a sine function, which means we are going to start on the midpoint, or start on the midline. And of course, our amplitude is positive, so we're going to start by going up and then going down. So I'm going to move this slightly. Okay, so again, we're going to start at pi over 2, adding pi, counting by pi halves, then from there going forward, pi, 3/2 pi, 2 pi, and then another 1/2 pi will give us 5/2 pi. I can now draw on my y-axis. I'm just going to draw it right here at pi halves. I can draw it really anywhere, but I'm going to draw it on pi halves. That's where I'm going to start. My amplitude is 2. I don't have a vertical shift. I just have a vertical stretch. So I'm going to count 2 above the midline, or the x-axis in this case, 1, 2, because the x-axis is our midline, and 2 below, -1, -2. Label that the x-axis. Label this my y-axis before I forget. And now I'm going to start graphing my function again. I'm supposed to start on the midline because it's a sine function. My value, this case, at pi halves, because I've shifted, I will start off at 0, okay? And then I'm going to increase to 2 after my first pi halves rotation. I'm going to go back to my midline at 3 pi, or 3/2 pi. I'm going to go to 2 below my midline at 2 pi, and then I'm going to finish at the back at the midline now at 5/2 pi. Again, this is a shift of my sine curve that would typically start at 0, 0. I've shifted it to the right pi halves units, and I've also vertically stretched it from having an amplitude of 1 to an amplitude of 2. All right, looking at this function now, here I have a number of transformations going on. We're just going to go with the transformations from left to right. First off, I see that I have an amplitude of 2, or my A value is equal to 2. So that is an amplitude of 2. Well, I guess if it's an amplitude of 2, here's the main idea. It's a vertical stretch of 2. I see that I have an h value here of negative pi halves. So we're going to shift it pi halves to the right. And then I have a vertical shift, a k value equal to negative 1. And that means I'm going to go down 1. I'm going to adjust where that is location-wise. It is a sine function. Excuse me. Because it's a sine function, I'm going to start on the midline. All right. Since I've shifted to the right pi halves, I start at pi halves, pi, 3 halves pi, 2 pi, and like the last example, ending at 5 halves pi. I can draw in my y-axis. And now when I draw my y-axis, one thing I want to realize is that I'm going to shift this whole thing down 1. So I'm going to, and I'm going to exaggerate it because I've already put in my, labeled my x-axis, but I am going to draw where y is equal to negative 1. This is my k value of transforming the function down vertically by 1. Now I'm going to apply my amplitude. My amplitude is 2, so I need to count 2 above negative 1. So if this is at negative 1, counting 2 above, 0 is 1, and 1 is 2. Counting 2 below negative 1, I have negative 2 and negative 3. Send that up. Okay. I've now taken into account my vertical stretch of 2. I've taken into account my vertical transformation of down 1. I've taken into my horizontal transformation of shifting pi halves to the right. Again, I'm going to start at my midline here. So I start at the midline where pi halves. I'm going to go up 2 at pi. I'm then going to go back down to my midline at 3 halves pi. I'm going to drop down 2 below according to my amplitude at 2 pi, and then I'm going to come back up to my midline at 5 halves pi. This still looks like a sine function. I have dropped it down 1 below the x-axis. I have increased it with a vertical stretch of 2, so that my amplitude in both cases here, amplitude is 2. We see all those transformations. And there we go. Of the curve. All right, so in this one here, unfortunately, we're back to degrees, radians. Kind of going to be the same thing, though, in the same process. Our first point is to determine the midline. I see I have an overall height at 1 and an overall depth at negative 3. If I think of the average between 1 and negative 3, that's a difference of 4. So 2 below 1 or 2 above negative 3, that would give us a midline at y equals 1. That means I have shifted at y equals negative 1. That means my k value is also equal to negative 1. The next thing I need to determine is whether I'm sine or cosine. Well, if I look at this, I start and I finish at the midline. Since I start at the midline, that is a sine function. So now I'm going to write sine of x. My amplitude's pretty easy to figure out. I go from negative 1 to 1, that is an amplitude of 2. Since I start going in the positive direction to begin with, I just have an amplitude of 2. There is no reflection here. So y so far is equal to 2 sine of x minus 1. I now have to come in contact with my horizontal shift. I would normally start it at 0 here. I'm starting at 90 degrees instead. That is 90 degrees right. 90 degrees right is going to be minus 90. So I could write it as y is equal to 2 sine of x minus 90 minus 1. But since I also know that 90 is equal to pi over 2 radians, I can rewrite this equation as y is equal to 2 sine of x minus pi over 2 minus 1. And that would be how I'd work backward from the curve to find the equation that fits it. Finally, this is our final example of the day. Looking at it, we should recognize this is a cosine curve, but we'll talk about why in a moment. Besides the fact that there's kind of two peaks and a valley in between them, that's typically what we think of a cosine function. All right, looking at it, our maximum height is at 1, our minimum height is at -3. That is going to give us an amplitude of, or a total distance of 4. We divide that by 2 to determine where our midline is. So again, our midline here is at y equals -1. That means k is equal to -1, and therefore I can start off with my k value as -1. Notice I start above the midline. Since I start above the midline, I know that this is a cosine function, and I also know, as a result, that my amplitude is greater than 0. Looking at our amplitude now, I go from -1 to 1, that is 2. I can also go from -1 to -3, that is also an amplitude of 2. So I now know that this is 2 cosine of x, and I now have to determine if I have a vertical transformation, or a horizontal transformation. We've already discussed the vertical transformation of -1. Well, typically I would start here at 0, so I have gone to the left. And by going to the left, I have gone to the left pi over 2. If I move to the left, that's a positive, so I have y is equal to 2 cosine of x plus pi over 2. So my function is y is equal to 2 cosine of x plus pi over 2 minus 1. All right, well, that's this assignment. You're going to get started on 11.3 worksheet, and best of luck to you.